4, 6. Looks like we've got 6. I think we have 11 students. So we'll wait just maybe 2 more minutes. Okay, why don't we get started? We are recording, so if people join late, they can always catch up later. So this is data mining, right? This is our IS 621 Business Analytics and Data Mining. It's meant to be a 4th semester class if you are a part-time student. It's a 2nd semester class if you're a full-time student. And I think we have 3 full-timers and 8 part-timers in this class. So what we'll do today, I think everybody on the call should know me from somewhere in the program, either from 607 or from last semester from 606, or just from various calls that we've done. But if not, so my name is Mike Schulte. I'm a data scientist. I'm part of the CUNY West Michigan Consortium, where Andy Catlin is also, as well as one of our math teachers. And so I work as a data scientist consultant. I used to work for a company called Blue Granite that was based in West Michigan, but I have since, I wanted to do some different things that they don't do, along with some of the things they do, so I work independently now, but I do a lot of work for them still. So I'm an independent contractor. I guess if you used to use my Blue Granite email address to get a hold of me, that will still work, but it would probably be better to switch to my CUNY address now. I know a few people used to use my Blue Granite address. I still have it, but you never know when that'll end. So, okay, so tonight just a brief course walkthrough will be the first thing we do, and then talk about a few things in terms of data mining, and in particular what the role of theory will be for our course and in general. And then I want to say a little bit about learning versus design. There are 2 different approaches to solving the kinds of problems we can solve with data mining. And then we'll take a look at the tools of the course, the software that you guys will be using, and then we'll take a look at a couple of the details for administering the course. So we'll talk a little bit about probability and statistics as a prereq, and then we'll talk more about meetup schedules. So let's start with the course walkthrough. Just a few high points. You should have been able to get into the course and look around, and I think everybody here, I think everybody in this class should be comfortable with Blackboard by now. Anybody not comfortable with Blackboard, please speak up and let me know, either now or in a private message. But I believe everybody here has taken at least one class with us already. So for now, we're going to use GoToMeeting for our meetups. We had talked about possibly using the built-in collaboration tools in Blackboard, but there are a couple of reasons that might not be desirable, not least of which is that it's very complicated to get started. And so we don't want to fuss with that too much. So I think for now we're going to stick with GoToMeeting. We may try that at some point as an experiment down the road in another course, not in this course, probably in the summer. For those of you who are interested, we are planning to offer predictive analytics in the summer, so that'll be the next course. And then we're talking about possibly one other, but that just isn't certain yet. Okay, so when you log in, you should go straight to the announcements page. You'll see something a little bit different from mine. Everybody can see my screen?
Yep.
Yes. Okay, good. So from announcements, you can go to the weekly materials, and again, you will only see the weeks that are active. I've got it set up so that the most recent material shows up on the top, but right now you probably well, I'll turn editing off and you should see what I see. So you should see we have a brief welcome video, and I won't repeat most of the stuff that's in there, but then you see the week 1 materials. And each week there will just be a brief agenda here so you know the various things that we need to do, and then you'll have lessons. This week's lesson is just a little bit of reading and get started with the course. But in future weeks you'll have labs, you'll have perhaps some video lectures as well, although less video lecture and more hands-on lab materials for you to try. And the lab materials will have solutions as well so that you can try it yourself and then compare with what we've got, maybe even improve upon what we have. And then once you've completed the lessons, you'll also have assignments each week. So this week there's just a brief introductory assignment due on Monday. So, and then there's also, just this week, there's one discussion board item. In this course, we won't have weekly discussion board items that are required, but there will be discussion board threads for each week if you need one. So you can start asking questions, discuss with each other. And you can see here, you guys will see the ones that are open, but we do have a thread for each week's materials. So feel free to use that. I will monitor those, but I probably won't answer questions in those threads right away, primarily just to give you guys a chance to answer each other. And if you really want an answer from me, the thread to use will be the Ask Your Instructor thread. All right, those I will try to answer as quickly as I can. If I think there's something worth clarifying in one of these threads, I will weigh in. But I want you guys to have the chance to do your own discussion. So I don't want to be the one who's got all the answers all the time. So feel free to use those threads, but I'm not requiring or grading that for the course. So, and then in future weeks, you'll see both a group and an individual assignment. And the group assignments are over approximately 5 weeks each. So it'll be assigned, the first one will be assigned in week 2. It'll be due, I believe, in week 7. So that's the longest of the 3 assignments. And then you'll see an individual assignment every week except the weeks where the group projects are actually due. And the individual assignments are really meant to be lower stakes. They're just meant to give you some tasks to show that you know how to do and to help you develop your skills. And then the group projects are really the applied projects for the course. So let me know if you have any questions on any of that. All the details are laid out here in the syllabus along with a schedule. You may notice I have yet to update the times for our meetings here in the schedule. Don't let that throw you. We have them in so many different places that I inevitably forget to change them in one place, and this was clearly the one. But for now, so we're still scheduled to meet at 6:30 on these Thursdays. Let's see, so will I be assigning groups? That was one of the things I wanted to ask tonight. Would people prefer to choose their own groups, or would you like me to split you up? We have 11 students registered, so I was thinking 3 groups. So 2 groups of 4 and a group of 3. What do people think? If you have strong feelings about whether you want to choose your own group or have me choose them, please let me know. If you're indifferent, you can, as Brian says, you can say you're indifferent and I'll choose them. No strong feelings. Okay. Well, if you do have strong feelings, especially if you say, I don't want to work with somebody in particular, then please let me know that privately offline, and we'll see what I can do. So I'll assign the groups next when next week's materials open up, which for the most part will be at the end of days Fridays each week, but this week's might open up Saturday morning. I have a couple more things I need to finish putting into place that didn't copy over correctly when we created the course. So most weeks the material will appear at some point on Friday by the end of the day. Okay, any questions on course procedures? Okay. If you do, please interrupt or type it into the chat box. All right, so let's talk a little bit about the role of theory in data mining. I've got just on the screen here some different books that I happen to have on data mining. and they vary tremendously in the amount of theory that's included. The two on the left, the Dean Abbott book and then the older book by Gordon Linoff and Michael Berry, have almost no theory in them whatsoever. They give you how to do the types of techniques, or they give you conceptual overviews of the kinds of techniques that are possible, but you won't find an equation almost anywhere in the book. Right? You won't find hardly any equations. And then on the other end of the spectrum, you've got books like the Foundations of Machine Learning book there that are meant for PhD students in statistics and mathematics. So in this course, we try to fall somewhere in between those two extremes. We're not expecting you guys to be writing newer and better algorithms as a result of our program, but what we do want to do is use theory a little bit here and there, and the reason for that is that theory really will help you practice better, right? So if you have a little bit deeper insight into the methods, then you're better able to use those methods. And in particular, we want to understand the limitations of different algorithms. One of the first algorithms that we'll study is called the naive Bayes algorithm, and it's loosely based on Bayes' theorem. But you need to understand some of the limitations of that, and in particular, it makes two assumptions. One is that all of the variables are categorical, right? So if you don't know that and you have a numerical variable in your model, you could get into trouble. And then the other assumption it makes is that all of the variables are independent, and that's not generally true. But if you don't understand these things, it's harder to know why your model might not work well. So we want to give you at least enough theory that you can understand the basics and the limitations of your algorithms and choose the one that you need. It's not often that I get to quote Karl Marx properly, but in this case I think he gets it right. Practice without theory is blind, and theory without practice is sterile. So we do try to walk a middle ground here in this class. We'll use some of the math that you've been building up, but we're not going to go too heavily into the mathematics. Okay, so the very first thing we should talk about is what machine learning even is, right? And you'll hear me use three different terms: predictive analytics, data mining, and machine learning, pretty much interchangeably. I don't really think there's much of a difference except from a marketing standpoint. You can make a case for different meanings for the three terms, but it really doesn't hold up if you look too deeply. So really, I use them interchangeably. The only thing we do sometimes tend to use machine learning more when we're dealing with big data. So we do have a course that we actually call machine learning and big data, and that course will use Mahout and Hadoop quite heavily. So that's the course where we use Hadoop. We probably won't get into it this semester. We might in the summer course in predictive analytics. That course is actually still being built, so we're not sure exactly when we'll fit different things in. But in both learning and design, we have this function f that takes as inputs a number of variables, and our goal is to be able to predict the output y. So you've got an output y, that could be a yes and no decision for classification, that could be an estimation of some numerical value, and then you've got a bunch of variables x that go into that in some function, and then we do allow for an error term epsilon. So there are two different ways we can try and make use of this function. In the first case, we use learning, where we don't actually know what the function really is. But when we use machine learning, we start with data, and we try to use that data to generate some approximation of the function. Right? We've got various techniques for doing that, and we're going to spend this semester and the next 2 semesters studying those different techniques. So the other approach then is design, and this is where you get into mathematical modeling more, where we believe we know what the correct function f is, and it's a matter of using and calculating with that function. So in design, you don't make any use of data. In learning, you make use of data. It all starts with data. They're two different approaches. They're both good approaches. It just depends on the circumstances. And we do have courses that teach you both of these different approaches. So you took mathematical modeling. Some of you took mathematical modeling last semester. That gets you started down the design approach path. And in this course, of course, we use the learning approach. But next week, what I'm going to have you do is one of each approach. So you're going to build a design solution to a simple problem. It'll have to do with identifying which coin is put into a vending machine. And you'll be given the information on the model that you need to build. We'll talk a little bit about the multivariate normal distribution. So you're not expected to know the multivariate normal distribution ahead of time. And in fact, we'll have some materials for reviewing just the univariate normal distribution, just the regular plain old bell curve distribution. And then you'll develop your solution and implement it in R. Let's see, Aaron asks if we can mix the two approaches. You can, but remember the whole purpose of machine learning is to estimate that function f. So if you already know the function, there's really not a need to try to use data to estimate the function. What you might do is try to use data to test whether that function is the correct function. But I don't know that we would even really consider that machine learning. I think we would really just consider that some sort of quality control.
So would you use the data to estimate parameters of a function? Would that be a machine learning technique?
No, that would be just more of a traditional statistical technique. And I'll admit that the border between the two can sometimes get fuzzy because we use regression in statistics, but we also consider regression to be a major part of machine learning. So there is sort of a fuzzy boundary there, but if you are certain that it's a linear combination of variables and all you're trying to do is estimate the coefficients, we typically don't think of that as machine learning. If you're trying linear regression as one of the possible functions, but you're also going to try some other approaches and see which one works best, then we tend to feel like we're more in the machine learning space. But it is kind of a fuzzy border. But you wouldn't typically build both a design solution and a learning solution. You know, either you would assume you know the correct structure of the function or you would not.
Okay. Thanks.
So the design solution will use the multivariate normal distribution, and you'll build a probability model, and then you just, when you're given a coin, you'd look up the coordinates in the probability model and see which coin is most likely to be the right one. So whether it's a penny or a nickel or a dime, that kind of a thing. In the learning approach, we'll build what's called a perceptron. It's a very basic model, and it requires the basic version of the perceptron requires data that can be separated linearly. So if you've got two variables, you can separate them with a straight line. If you've got three variables, you can separate them with a plane, and so on. So we'll review a little bit of matrix theory as part of that, stuff that you should have had in computational math. And then we'll also develop and implement this one in R. So I think this will be, this exercise will give you a pretty good feel for the difference between the learning approach and the design approach. And Aaron, maybe to elaborate a little bit more on your question, in a design approach, you might not even try and estimate the coefficients from data. You might just, like for our case, you might call up the U.S. Mint and say, what is the average weight and what's the standard deviation for a penny? Right? And then if they're willing to tell you, you just incorporate those into your model. So that'll be next week. And then once we've done that, then we'll move forward and look into the machine learning techniques that we'll study this semester. The tools for the course, I think I want to say just a little bit about that. Our primary tool is going to be R. So you're all assumed to have been trained in the basics of R. We'll look at some of the packages that implement the different techniques that we study. There are new packages coming out every day, and I know Brett Burke, for instance, will be on top of those faster than I am. So please do share if you find, and I think all of you are pretty good at this by now. Share if you find a new package that does something, or if we're doing something by hand and there's a package that does it, let us know. There will be a few times I'll actually prefer that you do something manually rather than use a built-in function, but I'll make it clear when that is. So like next week, I don't want you to look up how to do a perceptron using a package somebody has built. I want you just to code it by hand. You can, of course, use the functions in the base packages. But and if you ever have any questions, just ask. The second tool that we're going to make use of is a cloud tool. I've done a lot of work with Microsoft. This isn't necessarily an endorsement of Microsoft for machine learning, but I will say that right now I think they do have the most promising cloud machine learning environment that's out there. There are some others that are actually further along in their development process. Machine learning is still in, Azure Machine Learning is still in preview, but that also means it's free for you guys to use. But I think the potential for the Microsoft tool is really quite good. It allows, in particular, easy collaboration. So I can create a workspace, and then all I have to do to let you guys use something in that workspace is invite you by email. And then you guys can get into that same workspace. So it's easy to collaborate. It also has the ability to deploy models via web service. And that's something that others are starting to do as well, but the Microsoft team did a pretty good job of that. Now it is still in development, and so we'll run into occasional glitches probably as we go. One of which will be that they sometimes just change stuff, and then you have to figure out what they changed. But it's starting to stabilize pretty nicely, and we're starting to use it for real project work. So it's really getting pretty mature. So that'll be our second environment. And Azure Machine Learning has the capability to run R code. So if you can't find something in Azure that you need to do, you can always use R code to do it. The third environment that's open to you, of course, is Python. I confess that I am not a Python programmer. Andy Catlin is the Python programmer of the two of us. So I know very, very basic stuff in Python. And I'll be learning more with you as we go. But you do have that option available to you. And then the fourth option is MATLAB, or if you prefer the open source version, Octave. You can also use that. So the student edition of MATLAB is reasonably priced, and you should have access to that if you want that. If you prefer Octave, by all means use Octave instead. And now you don't have to use all of these. You do need to use R, and then what I'd like you to do is pick two of the other ones just to be proficient in the basics. And the reason we're having you do this is that there are a lot of jobs out there that are perhaps not quite going to be open to you unless you have exposure to some of these other tools. And so we want to help you be prepared to use some of these other tools. If all you can use is R, that does close some doors. So we want to at least be able to say at the end of our program that you guys know how to use R, you know how to use Python, and then you maybe know how to use either MATLAB or Azure Machine Learning. Maybe a few other tools will come in later courses. Certainly Hadoop will come into it. But we do want to develop a little bit of proficiency in some other tools. And so these are the ones we're going to start with for this course. So you'll have to pick two of them. And you cannot pick both MATLAB and Octave. So you'll have to use R and then two of the other tools. So if you're very comfortable with Python and you want to make that your second tool, that's great. And then you can choose between Azure Machine Learning and MATLAB. Any questions on that?
Hey Mike, do you have a recommendation in terms of what is like between Azure and MATLAB or Octave? Which one is more valuable?
I think it depends where you want to work. If you want to be an in-house data scientist at a big company, MATLAB might be the way to go. If you want to be more of a consultant or more open to startups, I think, then Azure Machine Learning might be the way to go. Not necessarily because they'll be using Azure Machine Learning, but it is a cloud-based environment. So there's probably some value to being comfortable working in a cloud-based environment. But if you're working in-house at a place like UPS or Pepsi or companies like that, you're probably not doing cloud-based work, at least not yet. So then MATLAB might be the more valuable of the two. I don't think you can go wrong, though. I think if you can put 3 of these down on your resume, then you're going to show that you can use a variety of tools. I think that's probably the most important. Because the tools are going to change all the time, right? I mean, 10 years from now, who knows what we'll be using. I know Ruby is starting to gain a little bit of ground in the machine learning world as well. And if I knew any Ruby, I'd make that an option too. But So who knows what the tool set will be 10 years from now. If you can show that you can learn new tools as they come out, that's going to be valuable. Any other questions? Concerns? Ruby programmers that are mad that I'm not letting you use it? Okay. One other thing to address, we do have formally listed as a prerequisite the probability and statistics class. In the fall, we ran into two problems with that. One is that the teacher that was going to teach it backed out at the last minute. Well, I shouldn't say it that way. That's judgmental. Circumstances changed and he couldn't teach it. So I was given the job of trying to patch something together, and it could have been better, right? So the other problem is that we have a full-time cohort for the first time ever, and after they approved that, they realized that statistics was supposed to be a prerequisite, but that you guys would be taking it in the same semester. And so we have some students who are taking 606 this semester who haven't been exposed to it yet. So what we're going to do then instead is review and develop theory as we go. It'll be piecemeal. We won't have a comprehensive statistics course as part of the data mining course, but we will review as we go. And if you need access to further materials, please do ask. I will give you guys, at some point I'll be able to give you guys access to some of the resources from the current 606 course if you're not already in it. But that, I think we'll just do that as we need it rather than giving you everything and asking you to review all of it. So what we'll use for this course is relatively limited from that statistics course. That's really more of a course for the design approach. So we'll just use the basics. One of the things that we'll use over and over, though, will be Bayes' theorem. So those of you who haven't had the course yet, you'll get that in the first couple of weeks. So you'll see that pretty well. And those of you who did take the course in the fall, we did cover that pretty well. So we should be okay there. And then the last thing is just the meetup schedule. We've been talking about, and I think the Wednesday night option has been nixed. We do have somebody who has a conflict there, so that one's out. But of course, I had put these slides together earlier. But there is a request to change the time and day of the meeting. We have a few options, which is to say I have a few options, and I'll put a survey together that asks you which ones you might be able to do. Wednesday, again, has been ruled out, but we might be able to do either Tuesday night or perhaps Monday night. So I'll put some different times and choices together for you. But I will say it requires everybody to be willing to do it, because this was our original scheduled slot, and so that's what people were told, and we can't change plans without everybody being willing to do it. So if we can find another time, I'm open to it. Mondays and Wednesdays I teach until 8 o'clock, so it has to be after 8. And then Tuesday we have other classes until 7. Until 8:45. So it would actually have to be pretty late on Tuesdays. So if we can find a time, that's great, but no promises. All right. That's all I really wanted to say for today. I think I'll open it up to you guys for questions, comments, concerns.
Good evening, Mike. This is Partha.
Oh, you were able to join us. Okay. Hello.
Yeah, I'm just getting into my garage, so I was driving and I was in audio for the last 15-20 minutes.
Okay.
But the thing is, as you said, that it's difficult to change the time. I don't know what to do and where to approach. I do not see myself joining at 6:30 any near future.
Right. So we're going to see what we can do.
And another thing is, I communicated about this time and date probably 4 or 5 weeks back, and I have been told that everything is finalized. There is no change, without knowing that this class will be at 6:30. So,
yeah,
so I don't know who decided that, and we have no role to play there. That's what I'm saying.
Yeah, I didn't either. Honestly, I didn't either. I was told that it was 6:30 on Thursdays. So But we'll see what we can work out, right? So we're going to see if we can put maybe 3 or 4 possibilities together, and if everybody can do one of them, we'll do that.
I would really appreciate that.
So start sending bribes to your classmates, and and we'll see what we can work out. I mean, I'm willing to stay up late. I made a comment earlier. I go to bed really early, but if we need to do later, that's fine with me. I also don't want to make somebody else who's used to getting up at 5 in the morning have to stay up until 10 at night. So look for a survey. I'll try and post it tomorrow. When I post the week 2 material, I'll just make it part of the week 2 materials, and then we'll go from there.
Thank you.
You're welcome. Anyone else? So I'm hoping that you guys have started to at least to get the books yet. The one that you need first is Principles of Data Mining. We're going to work with that for about the first 10 weeks. The Introduction to Statistical Learning book we'll also use during those 10 weeks as well as during the regression. But that one you can download a PDF file of for free. And so I believe I posted a link to that in the announcements. And then there's a new version of R in Action coming out. We're requiring that for the statistics and data acquisition courses for new students this semester. If you were in 606 but you were in data acquisition last semester, if you're a full-timer, then you don't need to buy it because you probably already have the basics. But it does have some good data mining material in it as well. So that might be a book to consider getting as well, the R in Action book. All right, let's see. So our next meeting is scheduled to be in 2 weeks. So there won't be a meetup next week. We will settle the time and the day. But the meetups will be roughly every 2 weeks. I say roughly because we have 2 holidays that change it slightly. Lincoln's birthday is on a Thursday, so with the original schedule we had to skip that week for both weeks, both classes, and so there's a 3-week gap there instead of 2, and then spring break also causes an extra week's gap. So, but in the fall we made the mistake of scheduling them every other week and then letting the holidays cancel classes, and that meant some of the classes went 4 weeks without meeting. So we've avoided that this time. So the full schedule is in the syllabus, so you can see which weeks we meet. And then I'll have office hours just about every week. So if you need help, we'll be able to do that. I also, because I'm an independent consultant, that means I make my own schedule for the most part. So if you give me a little bit of notice, we can generally find time almost every day if we need to meet. So just let me know if you need to meet. Other questions? Okay, so what I'm planning to do for the meetups is mostly have you guys present stuff that you're working on, and we'll talk more about that maybe at the next one once you've had a chance to dig into some stuff. We do want to give you guys a chance to start presenting some of your own work. I don't intend the meetups to be much in the way of lectures. I think there are better ways to deliver that material to you than for me to talk once every 3 weeks for an hour. So we'll do a little bit of that every time, but mostly it'll be you guys presenting, and then we'll go from there. So I'd really like to use this more as a working session. So, okay, unless there are any last-minute questions, I think why don't we go ahead and call it a night for today, and then look for that survey to see if we can figure out another time that we can meet.
So, Mike,
Yes.
one other follow-up on the
Okay.
design versus learning stuff. So I'm actually taking a class in probabilistic graphical models. So it seems like that's one that's sort of a combination where you put the structure to variables and then you learn different parameters of the system. based on data. Is that true, or am I misunderstanding
Yeah,
it?
I mean, it's that. I think you're starting to fall pretty heavily on that fuzzy border. But I mean, really, I think, machine learning is really just we don't know the structure of the function, and we're trying to approximate it with data somehow. And then we can do that to a greater or lesser extent, but I think once you move away from just estimating the function completely from data, I think you really do get more into a design approach. I mean, you're not ever going to need to go out in the real world and tell a client or a boss whether something was a machine learning approach or a design approach. I think it's just important to keep the distinction in mind that what we're really doing is letting the data dictate to us the structure of the function that we don't know. And I think when you get into the probabilistic courses, you tend to assume that there's a structure there that you might be trying to estimate how big some of the parameters are, or which parameters are significant, but really that's more pure statistics than it is machine learning. We do that though. The same people do both. It's not that there are these people in the world that are machine learners and then there are other people in the world that are statisticians, and that never the two shall meet. But I think it's fuzzy, and so we like to define things and have clear definitions and terms, and I guess I'm just gonna say don't worry too much about it. I think is what I'll say. Just be aware that there are these two different approaches to things. Yeah.
Fair enough.
And if that doesn't satisfy you, spend the next 40 years doing this stuff, and then maybe you'll have a better answer.
I'll work on that.
Any other questions? So you guys have the quantitative finance class after mine, right?
Yes.
Okay. So he does use a different GoToMeeting account and a different link. So do make sure you go to his to go to that class. I'm looking forward to working through that class and seeing what's in it too. I've only dabbled a little bit in quantitative finance, not enough to even dream of teaching the class. So I'm actually looking forward to. I'm one of the reviewers of that course, so I'm looking forward to it. I think that's going to be fun too.
Looks really interesting.
So, all right. I'm going to go ahead and end the meetup, and so I'll see you guys in 2 weeks on a date yet to be determined. But in the meantime, you know how to get a hold of me, and I'll have office hours. They're currently scheduled for Wednesday nights. I also have office hours on Monday nights for my statistics class. You're welcome to drop in, and they'll be welcome to drop into your office hours, but the rule is just if there is a statistics person there, they get helped first. So if there's nobody there and you drop in, then I'm happy to work with you, but each course gets first choice when it's their night. So shoot me an email, let me know if you need time, and we can also set stuff up. Otherwise, I guess I'll wish you luck with this semester, and see you in 2 weeks.
All right, thank you.
Thanks, Mike.
Thanks, Mike.
Thanks, Mike.
Good night.